What, because she wasn't paying attention?
Yeah, yesterday.
No, but, oh. I just meant when you were out, me and Cece would always be like, oh, it's from Kentucky.
Yeah, did you ever hear that? They would do a shout out to you?
I'm
Okay.
kidding, I'm kidding.
Okay. All right. Properties of exponents. I'm just going to do examples and give like an explanation of what we do for each one. So, product of powers. 4 to the 6th times 4 to the 3rd equals 4 to the 9th. And the explanation is we add the exponents when the bases are the same.
Wait, is that minus? Oh.
So 6 plus 3 equals 9. We add the exponents.
No, like, is that like a 4 to the power of 6 times?
Yep.
Yeah. Oh, I have minus.
Right, so that's our shortcut. What this is really doing here is I have 4 times 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 4. And how many 4s do I have? 9. So the shortcut is to just add the exponents. Right? That's our shortcut. Oh, we'll get there. Because the next one is quotient of powers. What is quotient? Division, right? I'm going to draw a little squiggly here so that these different examples don't get mix-matched. All right, quotient of powers. Four to the 7th divided by 4 to the 5th equals 4 squared. We subtract the exponents. So what this looks like is 4 times 4 times 4 times 4 times 4 times 4 times 4 divided by 4 times 4 times 4 times 4 times 4. So mathematically, 4 divided by 4, 1. 4 divided by 4, 1. 4 divided by 4, 1. Cross out what can be matched up, and what I'm left with is 4 squared over 1. So that's how I get 4 squared. But the shortcut is to just subtract them. We all love shortcuts, right? Now I'm using the base of 4 for all of these. You're going to have bases that are letters, numbers, all the things. So this next one I'm going to use letters. Oops, let me do my squiggle.
I just like watching it.
What?
I like watching it, like,
When I squiggle?
Yeah.
I've been perfecting it. I'm 20 years in. Okay. So if I have x to the 5th to the 3rd power. So power of power. this looks like it's up here at a weird angle. It's not supposed to be. It's supposed to be a regular parentheses, but it's hard to do. Here we go. And this answer would be x to the 15th. You can tell me why. What did I do here, Hayden?
You multiply them.
I multiply them, right? Multiply the exponents, because what this is actually showing me is x to the 5th times x to the 5th times x to the 5th. And wouldn't I just add those? Right? Because of our first rule, which we added the exponents with the same base. Do you guys need me to write out all those x's? I can do it, MJ.
Do it, yes.
Yeah? Okay. X times x times x times x times x times x. You don't have to do it. This is why we like shortcuts. Can you imagine if I made you guys write that out every time?
We would not like that.
Did you say you wouldn't do it? Or you wouldn't like it? Both? There.
Depends. Like, if the exponent was like 30, then I may not do it.
Okay, so this got a little wonky here because it's really, there's not a whole lot of room for the bigger loops. So sorry about that. All right, 0 exponent is the easiest one. Who remembers what anything to the 0 exponent is?
Zero. No, it's the number.
Uno. It's uno. Even if it's a variable. Any value to the 0 power equals 1. I'm going to show you. I'm so glad you asked. So glad somebody said how, because I can't wait to show you how that works. It's my favorite thing to teach in math. I'm going to show you.
It's just there's none of it.
But this is easier to know.
I know, I can tell. I love the enthusiasm. Okay. Is everybody done copying this down?
No.
Okay. You don't have to write this down. I just want you guys to look, listen, learn, be amazed. Okay? Because this is magic right here. Okay. So let's say we have 6 divided by 6. What does that equal? 1. What is 12 divided by 12?
1.
Okay. So we've established that anything divided by itself equals 1. Right? Everybody with me? Okay. So what if I had 6 to the first power divided by 6 to the first power? What's that going to equal? Yeah, because it's still the same thing, right? Right? Because any number technically has that secret 1 hiding there. Sometimes you have to acknowledge it, sometimes you don't. Okay. So this could also be 12 to the first divided by 12 to the first. And I'm going to equal 1. All right. You guys still with me? I don't want to leave anybody behind.
Yeah.
Just I'm almost there. I'm almost there. Okay. So we just talked about when we are doing quotient rule, what do we do to the exponents? I subtract them. So if I subtract 1 minus 1, what do I get?
0.
What? Anything to the 0 power equals 1. Do you,
But why?
because this is the same as this, which is the same as this, which is the same as this, this. Anything to the 0 power equals 1. Because it had had to come from something that looks like this, where the exponents are the same in the numerator and denominator. So if I had 35 to the 4th power divided by 35 to the 4th power, aren't these the same number? So they're going to equal 1. But if I do 35 to the 4th power divided by 35 to the 4th power, and I just subtract those, 4 minus 4 equals 35 to the 0 power. All the same thing. It's like this circle of awesomeness. So this was this, which came from this, which we all agree equals 1. Ta-da!
Okay, but what about 0?
What about 0?
0 to the 0. Like,
Yeah.
0 divided by 0, 1? I thought it was 0. It's 0 times 0. That's just 0.
0 divided by 0 equals 1.
Huh?
No.
No. Okay, so what that?
It's just a rule, guys.
No, it's not.
I don't make them. I just explain them as best I can and follow them.
0 times 0 is 0. 0 divided by 0 is 0.
Anything to the 0 power is 1. It's just what it is. This is the best. Don't overthink it.
I kind of got the other ones, but then when you said
Exact 0?
Anything divided by itself is
1.
1.
0.
But why 0?
Just is. I don't know what to tell you. Okay.
Because when you put a bracket on 0,
It says error on the calculator because it's not taking it. But if I put 0 to the 1st power divided by 0 to the 1st power, I'm going to get 1.
No, 0 goes into 0. But why is 1?
Huh?
Why is 0 divided by 0?
Because you're not supposed to divide by 0, but if it's 0 divided by 0, it's different. The calculator has it formatted that way.
Undefined.
Okay. Are we good? Can we move on? Addison, what is happening back there?
Can I go get my water bottle?
What are you eating?
Carrots. It disappeared.
What was it?
Really hot chips.
Go get your water bottle. Leave the door open so you get back in.
I'm gonna eat one more so I get the best experience.
Still recording. Still recording. Okay. We're moving on. Moving on. Negative exponents. This is everybody's favorite. If you have a base to a negative exponent, it's not really a thing. And I know that sounds like hocus pocus with math, but you should never have something to a negative exponent because you can't multiply something by itself a negative number of times, right? So what you have to do is transform it into a fraction where 1 is the numerator, and then all of a sudden magically the negative disappears.
So you don't have an explanation for why the...
I do have an explanation. I do. But I'll show you in 1 second. But I need you guys to remember that this is what you do to solve that problem. Wherever you have a negative, if it's in the numerator, right, then it goes down to the denominator. If it's in the denominator, you move it up to the numerator. Okay? So wherever you have negative exponents, they need to move to the other part of the fraction. Obviously, these are, everything has a denominator of 1. And then the negative with the exponent disappears. Right. So what I'm going to show you guys on the calculator now. Okay. So if I do, can you guys see that okay? 3 to the negative 4, I get this number. You see it? 0, 1, 2, 3, 4, 5, 6, 7, 9, and so on. Everybody see that? It's a really tiny number, right? Super tiny. If I do 1 divided by 81, which is what Avery decided 3 to the 4th is, and he's correct, I also get that same number. So a negative exponent is actually making a number that much smaller instead of that much bigger. But you can't write it mathematically. Like, it just doesn't look correct. So you have to rewrite it as a fraction, right? So that you get proper mathematical formation. I mean, it's just like a technicality, but this is what they want you to do. If I do it with this example, 1 divided by, and then I have to do parentheses, 5 to the negative 2nd power equals 25. 5 squared is 25. So that's how these are the same value. I'm not changing the value of anything. I'm just putting it in proper mathematical form by getting rid of the negative sign. Yeah? Okay. Let's move on to the next page. Slow and steady, guys. Slow and steady. Power of a product. Lots of words sound the same here. Nothing I can do about that. X times y to the 5th power. That's going to equal x to the 5th power times y to the 5th power. You distribute the exponent to each term. So I literally just did like that. So what I'm doing is I'm taking 5 times that 1 that's hanging out there with the x and 5 times the 1 that's hanging out there with the y. And that's why I get x to the 5th, y to the 5th. If I had something like this, I would distribute that 5 in there, but now it's 5 times 2 and 5 times 4. How are we feeling so far? Just bringing back fond memories from 7th grade. Are these things sounding vaguely familiar to you? No? You don't remember any exponents from last year?
I remember asking you some hair questions about this.
Who was your math teacher, Avery?
I didn't have one. I was on like the full online thing, and it was terrible.
Yeah, that's
I
not.
didn't have a teacher. We literally just did like slides for like 20 minutes a day, and then
Okay. Well, no time like the present to learn it. I was gonna say, if you had someone in this building, I was gonna go down and be like, "What's the story?"
it was like Miss Douglas or something.
Yeah, she just kind of facilitated it.
Yeah.
Okay, power of a product, right? We distribute in. These two numbers are being multiplied. That's why it's power of a product. Power of a quotient. Oops, I forgot to write the word example. X squared over y to the 4th raised to the 5th power. What do you think I'm going to do, Jackson? Same thing. I'm going to distribute this in. And I'm going to get it x to the 10th, y to the 20th. And then I can't do anything with this. I can't do 10 minus 20 or simplify this any further because these don't have the same bases, right? If this was x to the 10th, x to the 20th, then I could subtract those and get x to the negative 10 and then rewrite it as 1 over x to the 10th. But I can't because this x and y are different values. Yes, MJ? Yeah, I didn't, like, it's not super extravagant here. Oops, we forgot our squiggles. Those are better, huh? Those are upgrades. Okay, so here's something you guys need to be like comfortable. Remember we talked at the beginning of the year, like you're going to have to be comfortable being uncomfortable? Because you guys have, math is like your thing. It's always been your thing. Mom and Dad have told you since you were in kindergarten, like, you're so good with numbers. Like, look at you sort those cubes, right? Like, they've been cheering you on math for your whole life because it's just been natural. Like, you just get it. So this is where you guys have to be okay with not doing the exact same thing as the person next to you, but you're going to get the same answer, okay? Because the thing about simplifying exponents is my first step might not be your first step. I mean, there's a pretty good chance it's not going to be, but as long as you take into account all of the exponent rules, we'll get to the same answer, okay? So I'm going to show you, yes?
Will we ever have to, will you ever show us an example of a problem and have us say what power it is? Like, what rule?
No.
Okay.
No. I'm not going to make you guys memorize those because, honestly, I don't have them memorized. But I need you to know what to do when you see certain types of problems. Right? There's not going to be like a matching. No. That's not a good use of our brains. Okay? All right. So here we go. I'm going to show this example. And there's a couple different ways we could go about solving this. A couple different things we could do. So this is a perfect example of how my brain might be looking at this one way, your brain might be looking at it a different way. And it's okay. Who wants to tell me what you would do first to simplify this? What would you do first? What do you think, Jackson? Okay, so by multiplying these, what are we actually doing with the exponent? Adding. So you would get x to the 12th, and you would bring over x to the 14th. Perfect. Now there's really only one thing we can do. We're down to just two terms. What would I do with that 12 and 14? Kike. Raise your hand next time. Yes, we're going to subtract 12 minus 14, and we get x to the negative 2. And then we know we can't have that negative, so if somebody raised your hand, what would my final answer be? Vince.
1 over x to the power 2.
Perfect. So that's one way to solve it. Another way, and I don't know if that's how you all looked at it and you were like, yes, that's exactly what I would have done what Jackson did. Perfect. What other way is there? Well, there is another way. I could subtract the 8 and the 14 because they have the same base, in which case I would get x to the negative 6 times x to the 4th, and now this is gone, right? And then this would turn into x to the negative 2, which would turn into 1 over x squared. So I looked at this first, subtracted those, got the negative 6, added those, still have a negative 2, and then I get 1 over x squared. As your math teacher, I don't care which step you do first, as long as it's accurate, like a step you can do, and you get to the right answer. everybody understand? Yes. Everybody's good? Ish. Good-ish. Okay, we'll stop right there.